Welcome to another deep dive, everybody. Today we're heading out into the cosmos to explore the James Webb Space Telescope.
The JWST.
Yeah,
Yeah.
we're looking into not just what it is, but why it's such a big deal.
Yeah,
What mysteries are we hoping to solve with this thing?
absolutely.
And get ready for some mind-blowing imagery
Yeah,
from the deepest reaches of space.
it is really quite incredible.
All right, so to kick things off, let's compare the JWST to its predecessor, the Hubble telescope.
Okay,
They both look at space, obviously,
of course.
but they're designed to see different kinds of light.
Right.
Hubble mainly sees visible light, like what our eyes see, but JWST is built for infrared.
Exactly. And that's one of the key reasons the JWST is so important for understanding the early universe.
Oh, really? Why is that?
So the universe is expanding,
Okay.
and that expansion stretches the light from distant objects.
Hmm.
The farther away an object is, the more its light gets stretched or redshifted towards the infrared part of the spectrum.
So that's why the JWST needs to see infrared light.
Right, because the most distant and therefore oldest objects in the universe emit light that's been stretched so much, it's shifted into the infrared.
Wow, so it's like the JWST is a time machine letting us see back to the universe's earliest moments.
Precisely. It's like having a window into the universe's baby pictures.
That is awesome. The source even mentions that it could potentially capture light from the first generation of stars ever.
I know, that's incredible, isn't it?
Yeah.
And these weren't your average stars either. These were massive stars, hundreds of times larger than our own sun.
Wow.
Yeah. And when they died, they went supernova, seeding the universe with heavier elements.
So all the stuff that we're made of.
Exactly. You made this table, our planet, all made from the remnants of those first stars.
That's amazing. But okay, if they were so massive and bright, why haven't we seen them before?
Well, they existed for a very short time, cosmically speaking,
Okay.
and the light from them has been traveling for over 13 billion years.
So it's incredibly faint.
Very faint. It's a real challenge even for the JWST to detect.
So it might be like trying to find a needle in a haystack.
More like a specific grain of sand on all the beaches on Earth.
Okay, well, hopefully we get lucky.
We'll see. But in the meantime, the JWST is already revealing amazing things about the universe.
Speaking of amazing things,
Yeah,
infrared vision isn't just for looking back in time.
right.
Our source also says it lets the JWST see through these giant clouds of cosmic dust.
Oh, those are fascinating.
Yeah. Dust clouds are like interstellar fog, blocking visible light, but infrared can pass right through.
Like having X-ray vision for space.
Exactly. The source even showed a comparison of the Milky Way in visible light and infrared, and wow, what a difference.
That's incredible, right?
In visible light, you can barely see through the dust, but in infrared, it's like the dust just disappears, and you can see a whole tapestry of stars and nebulas.
It's like someone cleaned a dirty window.
Exactly. And this isn't just about pretty pictures either.
No, not at all.
Being able to see through the dust is crucial for studying star formation.
Absolutely, because those dusty clouds are where stars are born.
Ah, I see.
So the JWST can peer into these stellar nurseries and show us how stars are created.
Wow, that's incredible. Okay, enough about the invisible. Let's talk about something. We can see the JWST's massive gold-coated mirror.
Ah, yes. That's iconic, isn't it?
It's huge. The source says it's 3 times larger than Hubble's mirror.
It is an absolute behemoth, and it had to be folded up like origami to fit inside the rocket for launch.
Wow, it's like a cosmic transformer.
Yeah.
But why gold? It can't just be for looks, right?
Well, it does look stunning.
Yeah.
But gold is also incredibly efficient at reflecting infrared light, which is exactly what the JWST is designed to capture.
Oh, right, makes sense.
Yeah.
And I read that the mirror is made of beryllium, which is this rare metal found in emeralds.
That's right.
It's crazy. But why beryllium?
Well, it's lightweight yet strong,
Wow.
which is important for a mirror that needs to be both large and precise.
Yeah.
Plus, beryllium holds its shape even at extremely low temperatures.
Oh, because the JWST needs to be kept super cold, right?
Exactly. We're talking minus 233 degrees Celsius.
Wow, that's colder than the coldest temperature ever recorded on Earth.
That's right. And it needs to stay that cold to prevent its own heat from interfering with those faint infrared signals.
So it's like a giant super-sensitive thermometer in space.
That's a good analogy.
And any extra heat would mess up the readings.
Exactly. But luckily, the JWST has a massive sun shield to protect it from the sun's heat.
How massive are we talking?
The sun shield is about the size of a tennis court.
Wow, a tennis court in space. That's insane. But our source mentioned that one of the cameras needs to be even colder, like Manneka's 266 degrees Celsius.
You're talking about MERI, the mid-infrared instrument.
Yeah.
It's so sensitive that it needs to be kept in a special refrigerator cooled by liquid helium.
A telescope with a built-in fridge that's amazing.
It's quite an engineering feat.
Well, it's clearly working because the JWST is sending back some truly stunning images.
Oh, absolutely. Those images are not just beautiful, they're packed with scientific data.
That's what we're going to talk about after the break. Stay tuned.
Looking forward to it. All right, so we're back and ready to dive into those stunning JWST images.
Yeah, those images are incredible. But they're not just pretty pictures, right? They actually tell us a lot about the universe.
Oh, absolutely. Each image is like a scientific treasure map packed with information.
Okay, so let's start with that amazing image of the SMA CS0723 galaxy cluster.
The one President Biden revealed.
Yeah, that one. It's just mind-blowing.
It really is, and one of the things that makes it so fascinating is the way the galaxies are arranged.
Oh yeah, some are so bright and clear and others are like these faint little smudges.
Exactly. And that tells us something about the vastness of space and time.
So it's like we're looking through layers of history with the closest galaxies shining bright and the most distant ones fading into the background.
Precisely. And the JWST can see so far back in time that it allows us to study how galaxies have evolved over billions of years.
It's like a cosmic family album showing us how galaxies have grown and changed over time.
That's a great way to put it. And speaking of families, let's talk about those distant relatives, exoplanets.
Oh yeah, those planets orbiting other stars.
Right, and the JWST is proving to be quite the exoplanet detective.
Yeah, the source mentioned that it can actually study the atmospheres of these alien worlds.
And that's a game changer in the search for life beyond Earth.
So beyond just detecting water vapor, like they did with WSP-96b, what else can the JWST tell us about these exoplanets? Could it detect like oxygen or methane?
Potentially, yes. Those are all molecules that could indicate the presence of life.
So it's like we're taking a cosmic sniff test, analyzing the chemical fingerprints of these planets to see if anything smells alive.
It is a bit like that, although we haven't found any definitive signs of life yet.
Well, I guess we have to be patient.
Absolutely. The JWST is a powerful tool, and it's just getting started.
It's exciting. Okay, let's shift gears a bit and talk about how the JWST actually gets all that data back to us.
Yes, the data transmission process.
So it has a built-in hard drive, right? Like a cosmic flash drive storing all those incredible images.
That's right. It has a 68-gigabyte solid-state drive that acts as the telescope's temporary storage.
Wow. And I read that it beams down about 57 gigabytes of data to Earth every single day.
That's a lot of data. And to catch all that information, we have a global network of giant antennas.
It's like a cosmic game of catch, making sure we don't miss any of those precious photons.
Exactly. The Deep Space Network, with its massive radio antennas, is constantly listening for the JWST's signal.
It's incredible to think about the scale of this whole operation.
It really is a global effort, a testament to human ingenuity and collaboration.
And speaking of collaboration, the source mentioned that this isn't the end of the story. There's already talk about the next generation of space telescope.
Oh yes, the Roman Space Telescope?
It's named after Nancy Grace Roman, who was a pioneer in the field of astronomy.
That's right. And it's set to launch in a few years with even more advanced capabilities than the JWST.
Wow, so we're on the verge of a golden age of cosmic discovery.
Absolutely. With the JWST already making groundbreaking discoveries and the Roman Space Telescope on the horizon, the future of astronomy is incredibly bright.
I can't wait to see what we uncover next.
Yeah, me neither. The universe is full of mysteries, and we're just beginning to scratch the surface.
Well, on that note, let's take a quick break, and then we'll come back to discuss some of the challenges and risks involved in operating a telescope a million miles away from Earth.
Sounds good.
All right, so we're back. And, it's kind of amazing to think that this incredible telescope is out there a million miles away.
I know, it's mind-boggling, isn't it?
Yeah, and the source was talking about some of the challenges of operating something so delicate, so far away from Earth.
Right. It's not like we can just send a repair crew up there if something goes wrong.
Exactly. It's really out there on its own.
And space is a pretty harsh environment.
Yeah, they mentioned those tiny micrometeoroid impacts.
Oh, yeah. Those are a constant threat.
Even something that small could damage those delicate mirrors.
It's a reminder of just how fragile our technology is out there and the vastness of space.
But so far, so good. The JWST has been exceeding expectations.
It really has. It's a testament to the skill and dedication of the people who designed and built it.
It's almost poetic. This delicate instrument hurtling through space, capturing these faint whispers of light from billions of years ago.
It really is remarkable.
And all that data is helping us unravel the secrets of the universe.
Absolutely. The JWST is a game changer for astronomy.
And even though the JWST has a limited lifespan,
Right, 5 to 10 years is the estimate.
the quest for knowledge is never ending.
That's true. Our source even mentioned that the next generation of space telescopes is already being developed.
Yeah, the Roman Space Telescope, named after Nancy Grace Roman.
She was an incredible astronomer.
And it's going to be even more powerful than the JWST.
It will have a wider field of view, so it can survey much larger areas of the sky.
It's like we're entering a golden age of cosmic discovery.
I think we are, with the JWST already making groundbreaking observations and the Roman Space Telescope on the horizon. The future of astronomy is incredibly exciting.
And it's not just for scientists. Yeah.
Right, these discoveries belong to all of us.
They inspire our imaginations and remind us of our place in this vast and mysterious universe.
Exactly, and it's a reminder that there's still so much out there that we don't know, so much left to explore.
So as we wrap up this deep dive into the world of the James Webb Space Telescope, let's just take a moment to appreciate the incredible achievements of science and technology.
Absolutely, and the power of human curiosity.
It's that curiosity that drives us to explore, to push the boundaries of knowledge, and to seek answers to the biggest questions about our universe.
And who knows what amazing discoveries await us in the years to come.
Well, that's it for this deep dive into the James Webb Space Telescope. Thanks for joining us.
It's been a pleasure.